Hi, today we're going to talk about exponential functions. So the first thing that we want to go over is the fact that an exponential function is a function where the exponent is a variable or a letter. So for instance, examples of exponential functions are if I say y is equal to 2 times 4 to the power of x. Or I could say y is equal to negative 1/3 times 3 to the power of negative x. Anytime your variable is in the exponent, that means that it's exponential. So, for example, number 1, we are looking at function notation. So it says, for the function g of x is equal to negative 3x plus 12, we need to find g of 5. So g of 5 means that we are substituting 5 in for x. So if I have g of 5 is equal to negative 3 times 5 plus 12, and I substitute that into my calculator, negative 3 to the power of 5 plus 12, my answer will be negative 231. All right. The next question, it says we need to find g of 0. So g of 0 means that I'm substituting in 0 for x. So I'm going to have negative 3 to the power of 0 plus 12. So negative 3 to the power of 0 plus 12 is equal to 11. All right. The next question we have, it says we want to find g of negative 3. So that means that I'm going to have that this is equal to negative 3 to the power of negative 3 plus 12. So if I have negative 3 to the power of negative 3 plus 12, we end up getting 11.96. And then if we turn it into a fraction, hit math, enter, enter, we will actually get 323 over 27. All right, so that's how we evaluate exponential functions when we have function notation. So now let's talk about graphing exponential functions from tables. So anytime you want to graph a function, it is very helpful if you make a table of values. And once you've made the table, you just plot the points and connect them with a smooth curve. So we have y is equal to 1/2 x. So here I'm going to create a table of values, x and y. And anytime you want to graph a function, you always need to find numbers that are on the other side, on the opposite sides of 0. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. So if I put it in the calculator, I could say 1/2 to the power of negative 3. And that will give me 8. Now, I can continue doing this, or what I could do is I can use the calculator and let it do the work for me. So if I were to do that, all I would have to do is go to y equals, and I can type in 1/2 to the power of x, and then press second graph and go to the table. So I see that here when x is negative 3, y is equal to 8. When x is equal to negative 2, y is equal to 4. When x is equal to negative 1, y is equal to 2. When x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 0.5. When x is equal to 2, y is equal to 0.25. And when x is equal to 3, y is going to be equal to 0.125. So now we can plot the points. So I'm going to negative 3, 8, negative 2, 4, -1, 2, 0, 1, 1, and then 0.5. And then we have 2.25, 3, and 1.125, excuse me. And then I'm going to go when x is -4, even though I didn't put it in the table, but when x is -4, y is equal to 16. And so now that we have points, we can now connect them with a smooth curve. So I'm going to go like this. And then I can draw my arrows. All right, so now that I have done that, that is my exponential function. So now I can answer the question. So to the side it says, part A, if x is increased by 1, the value of y is, we need to fill in that blank. So as you can see here, as the x values go up by 1, the y values are being divided by 2. And instead of saying divided by 2, if you want to, you could say multiply by 1/2. It's the same thing. The next part, for part B, it says if x is decreased by 1, the value of y is going to be multiplied by 2. All right, so now let's look at end behavior. So end behavior is referring to the way the graph works as x gets very, very small or x gets very, very big. So the first part for part C says as x approaches positive infinity, if x goes to positive infinity, that means that x is going to the right forever. So as x goes to the right forever, the y value here is getting close to 0, but it's not going to touch. And the reason why I'm saying this is because if I look at the table, if x is going to positive infinity, that means that x is going to keep getting bigger. And as we can see here, we start seeing for the y values that we're going to have numbers in scientific notation because we see the e and then we have some negative numbers there. So if I scroll over, you will see when I scroll, that is about 3.73 times 10 to the power -9, which means that I'll be moving my decimal back 9 times, which means I'm going to have like 0.00000000 and then the numbers. So that means that I'm getting very, very, very close to 0. So as x approaches positive infinity, y is getting close to 0. On the contrary, on the other end, as x goes to negative infinity, meaning as x goes to the left forever, the y value is going up forever, which is to positive infinity. Okay, so now let's talk about domain and range. Domain is referring to how wide does the graph get. So the domain here is going to be all real numbers. And that is due to the fact that you're going left forever and right forever. Now the range is referring to your y values or how high or how low your graph gets. So we see that the graph is going up forever. So I know that my y is going towards positive infinity, or I can say greater than. But we can see that the lower part of the graph is not going down forever, but instead it's going down and then it's going to level out. So we can say the range is going to be y has to be greater than 0, because remember, it's never going to touch it. It's just going to get very, 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 very close to it. All right. So now let's look at graphs of exponential functions. When sketching exponential functions, we need to focus on the following 3 things below. The first thing is the horizontal asymptote. Remember, that is the horizontal line that the function gets really, really close to, but it never touches it. Sometimes it looks like it's laying right on top of it. All right. So the next piece that you have to look for is the y-intercept. The y-intercept is the value of y when x is 0. So if you have an equation, substitute in 0 for x and then solve for your y value. The next thing you need to do is you need to locate two other points. And the way you do that is that you pick two x values and then you substitute them into the equation to find their corresponding y values. So let's look at example 3. So it says sketch the function y is equal to 3 to the power of negative x plus 6. So it says find the horizontal asymptote. So the first thing I'm going to do is I'm going to go to y equals, and I'm going to type in this function, y is equal to 3 to the power of negative x plus 6. When I do that, I want to look at how it behaves. So the first thing I'm going to do is I'm going to graph it. Okay, so I know that the asymptote is a positive number because it is above 0. So now I'm going to look at the table. So when I look at the table, as you can see here, I see a whole bunch of 6s, but I just want to make sure. So I'm going to go back to where x is 0. So if I go to second window to go to my table settings, I can put that I want to start at 0. Go back to my table, and then I can clearly see that as my x values get bigger, my y values get closer and closer to 6. It looks like it is 6 exactly. However, if you highlight it, you will see that it is really, really close to 6. And the decimals keep going. And then finally, it'll just level out. And it's not that it's equal to it, it's that it doesn't have enough space on the calculator to keep repeating numbers. Okay? So if we do that, we know that our horizontal asymptote is 6. So that's going to be y is equal to 6. That's my equation. So because I know that that is my asymptote, I'm going to graph it with a dotted line. So this is my horizontal asymptote here. All right. So now the next thing I want to do is I want to find the y-intercept. Remember, the y-intercept is the value of y when x is 0. So all I have to do is substitute in 0 for x, and I will end up having y is equal to 3 to the power of negative 0 plus 6. And we know that anything to the power of 0 is 1. So that's basically 1 plus 6, which is equal to 7. So my y-intercept is at a positive 7. So if I graph it, it is going to lie here. All right. So the next thing we have to do is we have to find two other points. And what I want to bring your attention to is if you look at the calculator, if I go back to my table settings and start at 0 and look at my table, you will see that the y-intercept is 7 because you have the x value of 0. 0, 7 is the y-intercept. So you could tell what it is in the table as well. So now let's find the two other points. So the two other points can come from any of the x or y values. So let's say if I want x to be equal to a negative 2 and x to be equal to a positive 2. So all I would do is substitute those values in. So I will have 3 to the power of, and let me put a y equals here so you won't forget that. So y is equal to 3 to the power of negative x, but if I say negative 2, that will turn into a positive 2. And then I will have plus 6. If I substitute in positive 2, that will be y is equal to 3 to the power of negative x. Well, if x is 2, that would just be negative 2 plus 6. And of course, I can put that in my calculator. and these will be my values. So I will get 15, and then I will get 6.1 repeating. So now, if I want to, I can just go ahead and plot these. So -2, 15. So if I plot -2, 15, I am here. And if I plot +2, 6.1, +2, 6, 6.1 will be somewhere like right here. That makes sense because I know it's supposed to level out. So now all I would have to do is connect these points with a smooth curve. It doesn't have to be perfect, but try not to lift your pencil or pen. All right. So that's the way that graph looks. All right. So now let's look at example number 4. So it says this graph shows the curve y is equal to m times 2 to the power of x plus p, where m and p are constants. Find the equation of the function. So basically what we have to do is we have to write our equation to look like this that I'm highlighting, and we have to have specific values for m and p. So one thing that you should notice is they gave us 2 points, 4, 6, and 2, -3. So we're going to use those to create 2 equations. So if we look at 4, 6, if I create that equation is going to be 6 for y is equal to m times 2 to the power of x, which is 4, plus p. Okay, and then we will have the other equation, which would be -3 is equal to m times 2 to the power of 2 plus p. All right, so those would be our 2 equations by using those points. So now what we're going to do is we're going to simplify them a little bit so that they look a little neater. So this equation at the top will be 6 is equal to 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. And that will be m plus p. And then the bottom equation will be -3 is equal to 2 squared is 4. So we will have 4m plus p. So those will be the 2 equations. So now what we can do is we can put these 2 equations into the calculator using the Polysymbol 2 app. So if we go to apps and we go down to the option that has Polysymbol 2, you press enter to start it, and we are choosing the simultaneous equation solver. Remember, simultaneous equations is the same thing as saying systems of equations. So we have 2 equations here, and we have 2 unknowns. So we can then press graph to go to the next menu. So now remember, when you're on this screen, I am using an older calculator. I am only required to put in the coefficients. So when I enter my coefficients, I'm going to enter them in as 16 m plus 1p, so the one goes in the next one, is equal to 6. The next one I will put in as 4m plus 1p is equal to -3. If you have the updated TI-84, you will actually see the letters x and y. Okay? So once we put our coefficients in or our equations in, we'll press graph to go solve. And then we'll see here that we have that m is 3/4 and that p is -6. So when we write out the equation, it will be y is equal to m, which is 3/4 times 2 to the power of x plus p, or plus -6, which is -6. All right, so that will be the equation of that exponential function. All right, so if you have any issues with graphing exponentials or evaluating exponentials, please let your teacher know, and have a great day.